Welcome G7s. Today we're going to be looking at data collection and processing. It's the second part of the scientific method. You start with first planning, then data collection and processing, and finally you would end with your conclusion and evaluation. Now the first part of data collection and processing is your raw data table, and it's actually a bit of transition between the planning and your data collection phase. The raw data table is the table that you use during the actual experiment to record your data. So while you're actually doing the lab, you would have your raw data table out and be recording your information, your data in that raw data table. When you set that table up, you make sure that you set up the independent variables on the left column and the dependent variables in the right column. And very importantly is that you actually complete this before you do the experiment. You don't want to be halfway through your experiment and then realize you've forgotten to actually record your data, or be trying to figure it out while you're also trying to watch something on the Bunsen burner or something that's changing very quickly. You need to be prepared to do that ahead of time. Now, your raw data table is not raw in the sense that it's messy, but it's raw in the sense that you aren't going to actually do any calculations. You're only recording the numbers. Also, while doing the experiment, you should be recording any observations, or you should do this immediately afterwards. It's where you would describe anything in words that's not in the data table. If there's any qualitative data, color change that you maybe didn't have a place for in your data table, or you smell something funny, anything that you can think of that maybe would be important for the conclusion later on. So that's where we also, anything that seems different or strange, leading up, giving you things to go back to for a later evaluation, are important. After you actually finish your experiment, you need to process your data. And this part of your lab report is where you would use words and math to describe what the data table says. This is an actual process that you're going to do. And you're going to be looking for any kinds of patterns or trends in the data. Increase, decrease. Is there anything that you can see that would lead you to believe there's a pattern in the data that would help you in your conclusion? But it's also where we need to change the data. You need to calculate maybe a mean or a median, a mode, range, or all of them. Maybe that's a total. Maybe that's a difference. There are plenty of other calculations. You need to think about what is an appropriate type of calculation for the data that you have. You also need to make sure in your data processing that you have recorded in that part of your lab report what you did. If you did the mean, you need to include an example of how to calculate the mean. Include the formula and show an example. If it's you're finding a difference or a percent, record the formula you used and an example of how you've done that. That's an important part of the data processing. You then would take all of those answers, all of that data that you've just gone through, all the means, and put them into a processed data table. It's a new table with processed data. It's not an extra column on your raw data table. Okay? Make a brand new table, and because it's processed, it will be smaller. You're only going to have the independent variable and the processed data. Okay, so independent variable and one column for the mean. If you've done the mean and the median, you would have the mean and the median next to the independent variable, and so on. So it is a much shorter table. Okay. After you're done with that, you're going to need to complete a graph. Don't forget the independent variable on the x and the dependent variable on the y-axis. And you should probably graph the processed data. Don't try to graph every single point of data. Graph the means or graph the medians. Take your processed data and use those as your reference in your graph. Okay?